Is space completely silent? Many will have heard the explanation that in space, nobody can hear you yell, in the same way as others before you. You may have basically acknowledged this as reality without giving it any more thought on the point. Some may have even dove further and discovered that space is quiet since sound can't go through a vacuum. While both of these things are valid, have you at any point asked why? To get to the base of this, we have to explore the science behind it. All in all, space is a vacuum. However, what does that truly mean? We as a whole know about this thing called space. However, what precisely is it? To lay it out simply, space is everything that you can discover outside Earth's climate. In spite of being loaded up with stars, planets, space rocks, etc., space is attributed to as a vacuum. A vacuum technically implies a space completely without matter. Inside a vacuum there is literally nothing. No particles, no air, nothing. So how is space a vacuum, if there are such a significant number of cosmic bodies filling the night sky? All things considered, notably, space isn't really a genuine vacuum. It's referred to as such for our comfort, as space is such an enormous place, that most by far of it really is a vacuum. On account of sound waves, these mechanical waves come as a vibrating wave that transports energy as it moves, starting with one place then onto the next. This wave needs to go through what we call a medium, which for this situation is through particles. How about we take an example to make it a little more clear? For instance, you play a string of a guitar, the string vibrates. This initial vibration makes a chain reaction in the particles around it, in a way not too dissimilar, all like the ripples from a rock dropped into a lake. Every molecule influenced then exchanges the vibrations onto those around it, transferring energy. The further the sound wave travels, the more fragile the vibration becomes. This occurs until the sound wave stops to exist, because of a modest quantity of energy being lost in each move between particles. In this way, for sound to travel, we need particles. These particles can make up an entire scope of things, including water, gas, fluids, or even solids. Sound can't go through space, however, as it is a vacuum. If you played a guitar in space, you wouldn't hear it. There are no particles in the tremendous gaps of nothingness between cosmic bodies in space to vibrate, and in this manner the initial vibrations of the guitar string wouldn't have anything to move to, and nobody could ever hear it. In what manner can space be silent if it is not genuine vacuum? While by far most of space is a vacuum, and in this way totally quiet, there still are a few areas that sound can be heard. But wait, doesn't this go against everything that I've said until this point? Not exactly. All through the universe dust storms and gas can be found. These can be the remaining parts of long-dead stars, or even regions where matter is being pulled together to shape another one. In these space-faring clouds it is feasible for the gas and dust to get clustered, and therefore dense. This means it's really feasible for there to be sufficient particles close enough together for sound to happen, and to try and travel a little distance. A case of where sound in space happens is inside black holes, yet shockingly, it's humanly difficult to hear. This sound was first recorded in 2003 at NASA's Chandra X-ray Observatory, and it originated from the Perseus galaxy more than 250 million light-years away. The sound was estimated to be a B-flat, however at a frequency billions of times lower than is truly feasible for people to hear. Alright, so wait, is space totally quiet or not? While space is more quiet than you would ever imagine, it's not totally without sound. Sound waves can't go through space, yet there are some infinitesimally small regions where sound can exist, under very specific conditions. Thanks for watching.